Hello, and thank you for joining me for the third data analysis bootcamp, getting into our first Hell Week, Pandas plotting function. These are really good plots. They are super quick and easy, and I find that I use Pandas plot, although maybe it's not the plot that I use the most for presentations. In my data analysis, my exploratory data analysis, I would say I use it about half the time, and maybe even Pandas a little bit more because it's so quick and easy to use. Before we get started, let's recap our mnemonics from the last class. Okay, so when we were talking about what a data analysis really does, okay, really what the rules are. So we talked about when we get started, we remember we were sitting down at our desk, and when we sit down at our desk, we want to decide where to go from here. Like what do we want to explore the most? Because there's so much in any data set, even a small data set, there's so much to explore. So we really start with understanding our distributions to help us understand where to go from here. What we're really trying to do is simplify our distributions usually to a summary statistic, right? We had that poster in front of our desk to help us remember that we wanted to get to the point of summarizing and understanding which or what type of distribution, the shape of our distribution is going to help us understand how there could potentially be a skewing or a misunderstanding, misinterpretation in this summary statistic. And we need to be aware of that when we're presenting our results. And if you remember, there's that bang, bang, bang noise coming from the room next to us, and that was them doing their hypothesis testing. Important step, kind of annoying being in the next office, in the office next to us, but the hypothesis testing is such an important step, and the shape of our distribution will enlighten how or let us know how we can best perform that hypothesis test. The last time we saw the moon, the full moon, I was outside of my apartment when I saw the moon the last time. And then remember from there, we were standing there and there was all this data coming down from the moon, raining down from the moon, which is a weird situation. So we kind of classified that. We decided to say, well, that's the situation that would be outlier data. And as we want to be careful of our distributions. Distributions will give us an idea how we would set that threshold of what is or is not an outlier. The data that was raining down was starting to skew our view, our understanding of the world around us. And so we have to be aware of the skew and the kurtosis in our distributions because that will affect the summary statistics and how we can interpret those. And like an exponential distribution, which has a lot of skew, or even just a normal distribution that's leaning one way or the other, will change what that summary statistic, the most appropriate summary statistic is. And we were also concerned, as the outlier data was raining down from the moon, how would it affect the relationship? Our relationship. Our friend was coming up to see us, and we couldn't really see him that well anymore. That's the same thing. Our data set, as we look for the relationships in our data set, we want to be concerned, maybe look for how things are related to each other, the skews, if we're seeing patterns between all of our distributions that will it's not a bivariate analysis in a true sense, but it will start to give hints of what we should be expecting to see as we get to the bivariate analysis. Not that you have to do the univariate analysis first, but that's usually typically where I would start. We talked about really what we're trying to do from our sample of data that we have. We're trying to make inferences on the population. And so although it looks like we might have a lot of data, we always have to keep in mind that we have just a small sample, and we really want to take that to heart because that is going to affect the robustness of any summary statistic we have, okay, in understanding the population. Talked about, and we'll get a lot more to this in later classes, but we talked a lot about the histogram plot and how important it is really to understand the data in by generalizing, getting rid of some of the noise, and really help us see the shape of our distribution by removing some of that. And we'll get into a lot more how the histogram plots, but it's really one of the fundamental, one of the starting plots that you usually typically do in univariate analysis. We talked about our different distributions. We talked about the distribution that's equally likely to or equally likely to occur, or every data point is roughly equally likely to occur, and that is the uniform distribution, just like our pythons wearing their nice uniforms, very all looking the same here, just like our uniform distribution. Talked about it. The distribution that has the symmetrical on both, that is symmetrical on both sides, or the ideal situation would be that it's symmetrical. There's the normal distribution, just like our symmetrical looking python here. We talked about time between events, and that is often occurring in financial data. It represented in financial data often, or other time series type data, we'll see this exponential distribution with a long rate tail. We a tricky one to use, and we'll come to how we can deal with those distributions. Another really important one is the categorical distribution, and we talk often about the balance, imbalanced or balance between the different classes in our category here, the white and black Python. Where's the balance between those classes in our distribution? We talked about how sometimes there's many things you don't understand in your data. They don't follow a normal sort of pattern in distributions. And we want to, instead of just racking our brains, we really want to talk to an expert in those situations and see really if they can guide our analysis and help us understand better what we're seeing and why we're seeing it. We talked about how when we're looking at a normal distribution, or really in any distribution, the outliers, like our outlier gentleman here, it will pull the mean towards it. And on a simple basis, if it's affecting the mean, it's going to affect a lot of other statistics in our analysis. So we just have to be aware of those outliers. It's amazing how much of an impact they have. So we have to be conscious of them. Depending on what we do them depends on the situation, but we need to be aware of what they are. It's just like he's pulling the moon and the mountain towards him. They're going to pull a lot of our summary statistics towards the outliers. Okay. Talked about ways to deal with an exponential distribution. Common ways would be to bucketize. We're going to change it into categories 1, 2, 3, 4, category A, B, C, instead of a medium, small, medium, and large, instead of having that long tail, and that will essentially remove the effect of that long tail. Another option is to do a log transformation. This is the one that I would say I typically do, in the sense that it now converts or attempts to convert our exponential into a normal distribution, which is kind of the ideal distribution we want, where the average is really right in the center of the distribution, really where the weight of the distribution is. We also talked about ways to define an outlier. And using the classical definition, we have our IQR range, which is the 25th percentile to the 75th percentile, and 1.5 times on the outside of that is our classic definition of an outlier. It's good to stick with that classic definition, because as we'll see in later classes, the way you manage and the way you handle your outliers will affect your summary statistics. And so straying too much from that without a good valid excuse raises the question of, were you doing that just to get the summary statistic you wanted to find, or did you truncate your outliers? Did you treat your outliers in a really common sense way that would make sense for this data set? Okay, so getting started with our third data analysis bootcamp, held week 1. And I really think of these classes like a toolkit. Even if you don't remember everything in this class, it's really about having this information available. Keep it somewhere nice and organized in your drive, on the cloud, so you can access this from anywhere. ChatGPT is really fast, but if you have it in your notes and you know exactly where to go, how to find things, it is truly a lot faster. So that's what this is supposed to be, a toolkit class, like a really hell week going through everything and anything in Pandas. And so then when you find some situation to use these, you don't need to think hard about how to do it. You have the information saved in your kind of second brain, a very organized place for your Python knowledge, your data science knowledge. And it's very common. You can't be expected to remember all these stuff. Let your fingers remember it by typing it out many times, and you will eventually remember it a lot faster than your stupid human brain will remember it. So let your fingers remember it. Keep this knowledge somewhere safe, and if you don't remember everything, that's okay, because you can come back to this data set, this class, and all of the other classes that are like the hell weeks, or this immense amount of just knowledge going through all of these plotting functions. So getting into our first one, the area plot. And this is a handy plot. This is more of a specialized plot, I'd say. The situations where you want to use this is most commonly used in a time series data set, and really when you want to show how variables are moving together. So we can do a couple of cool things. We can stack things on top of each other, or we can, not stack things. And so I think in that situation, you get a really good sense of how they truly move together, right? Starting at 0, and how are they moving up and down together. You can see here, the red, the blue, and the yellow, they all tend to move together, but then this one seems to go in an opposite direction. And that is not truly something that you would have noticed in a lot of other situations. You really get that kind of flow, how things are really like the traffic here, how things are moving together, and if they're not, if they're diverging or going together. So it's, again, it's more of a specific situation. That is, lots of the pandas plots are very specific in the situations where you want to. There's some very high level plots and some very kind of common plots, but they're really these situations where you use them in specific situations. This is a really good plot. Again, when the situation calls for it. Okay, like we introduced in the last plot, the histogram. It really is fundamental, or kind of the starting point for most of your data analysis, your univariate analysis, really your overall EDA in general. It's usually the first thing that I do because it gives you such a good sense of the distributions. It generalizes the data in the sense that what it's going to do is it's going to, in each one of these bins, it's going to put a certain level of, or certain, it's going to count the amount of data, the amount of time it occurs in that range. Okay, this does it almost is like if you were to have a larger sample. This is how the distribution would look. It's going to remove a lot of this noise, like you can see here. You still see the shape, but you can still see some noise in this image right here. And what it's doing is it's generalizing. It's going to really show us just the outline of the distribution. And it's kind of like you were to assume you had more data, what would the distribution look like? And so we'll generalize that. Detail is important. Lots of the time, detail can be harmful even for our eyes as us as humans, can be deceiving. So when we want lots of just detail, there are other plots that we would use. This is a good starting point because we get a sense of the data, and then we can figure out, do we need to go into more detail, or can we, which one specifically, which distributions are worthwhile to go into a lot of detail. And so we'll have choices over the number of bins that we can control. A cool thing in Seaborn is that we can control the figure size. Right in the plots is very quick and easy. And one of the things that I love about this histogram plot is that we can do the log transformation, like we learned about in the last class. We can do this right inside of the plot. So we're not really changing the distribution, we're just changing the plot so that we can get a sense of it. We often want to change the actual column as well and maybe create a secondary one of the log transformation. But here, if we don't want to, we can just test it. It doesn't even make sense to do that in the first place. Just do it kind of on the fly in the fly. It's a very powerful tool and a quick and easy tool. Okay, getting into the classic, one of the classic plots that we have access to, the scatter plot. Scatter plot is really great for visualizing relationship between x and y. We can see here, we can really clearly see the trend here. We can also see this interesting kind of threshold where no matter how large x is getting, y seems to be truncated or not able to go, well, not generally not able to go past this threshold. Very interesting. We're able to notice this very quick and easy. And it's great. Scatterplot is a good starting point for a bivariate relationship. But one of the downsides is there's often just too much data in DNA in this day and age. So you can't really, down here, you can't really tell if there's more over here than over here or up here in this threshold. How much data is really here? And there's a correlation that shows strong correlation, but where is that correlation being supported by? And that's beta. I even turned on the alpha, and you can still see maybe a little bit less data right here. It's very hard to really have any statistical analysis, even a very valid visual analysis with the amount of data in this. So this one thing you have to be conscious of is scatterplot works well. But we often have so much data in the modern age, and normal data set is often too much data. We have many other plots that we can go to in these situations to enhance, to compensate of the kind of lacking of the scatter plot, and the fact that we just have so much data this day and age. It becomes confusing to really understand exactly what's going on in detail in the scatter plot. Okay, so getting into the pie plot. Now, this is honestly, it's not really a plot that's loved a lot in data science. I'm originally from finance, and so you always describe an investment portfolio as in a pie plot as a proportion of the whole. I think there's the reason that it's not loved in data science is there are some issues with this, and this has to do with how our eyes interpret proportions. So as we see things of a circle, our eyes just are not necessarily good at seeing those. So we can tell that maybe this browner wedge here is bigger than the other. It would be very hard for us to see exactly how much, right? And that's just our eyes. It's not something that our eyes are good at seeing. There are other things that our eyes are very good at seeing, and this is one of those situations where they're not. The simple way to fix this is we can note this. I think that's a really important thing is whenever you're going to do the pie plot, you want to make sure that you note and put the amount. In Pandas, there's a really cool effect that we can do is we can explode this as well, kind of like our exploding pie here. But we can explode it so that one, I think if you were thinking of a presentation, you could say, okay, we're going to focus on this area, we're going to section up this and explode a little bit more one of these sections. And so you can kind of highlight and talk about certain wedges. I think it goes really well in a presentation. So it's a good little trick that Panda has and makes quite easy for us to do here. Okay, so talking here about the box plot. Now this is just truthfully a really, really simple plot in lots of senses, and that's the idea here is we're going to simplify the whole distribution so that we can concentrate on outliers. That's really we want to use this to really identify, make it simple and easy to say here are outliers. Well, here's not an outlier. So it does the 25th to the 75th percentile is the interquartile range. This box right here, the mid-range of our data. 1.5 times on the outside of that, we would define as our classic definition of an outlier and a plot here as well as follows that traditional definition. I guess the idea here is it generalizes, you get no detail but very little detail about the whole distribution, and then really identifies when there is an outlier. Right here we have a few outliers just on the side. Really very valuable, again, when you just want to concentrate on your outliers. And really, that's the idea. That would be the goal of this plot. And I would say that that's when you mostly use it, is when you're looking, okay, do I have outliers here? Yes or no? You don't really want to concentrate on the rest of the distribution. Or in a presentation, if you want to kind of highlight the outliers here, it's a good plot for discussing outliers. The scatter matrix. Now it looks a little bit busy here. I only looked at 3 columns here in this little graphic here because it can make it quite busy. And really that's the goal here is when you do bivariate analysis, you're gonna have so many bivariate relationships to inspect. Which ones are important? You can't really spend time doing, the 100 combinations or the 200 combinations. So this is a good plot to use about kind of what to explore next. Where am I going to see some relationships in terms of my bivariate relationships, and what do I think is worthwhile to explore a little bit further, a little bit deeper? Here you have some interesting very tight linear relationships between x and y. And here you have kind of an interesting truncating thing that's going on that we discussed earlier. And it's very interesting, right? So you just our eyes. This is something our eyes are really good at seeing is identifying little patterns and trends, even from a distance. And now we've isolated, instead of looking at all of the relationships, we have a couple of plots that are worthwhile to go and explore in more detail. Okay, this is really the important thing is not usually the final plot. Don't get overwhelmed by this. Just see if you notice anything. Your eyes are really good at that. And then your final, this would be the step 2. What do I go next to? Where am I going to go from here? It's like our Indiana Jones. Where does he want to explore? Kind of the idea is where do we want to explore from here? Okay, so getting into our correlation, our autocorrelation plot. This is a really valuable plot when you're dealing with time series data. A little bit more specialized for that situation. And really what it's going to allow us to do is if we look at this lag, so saying today is correlated with 1 day in the past, 90%, 2 days in the past, 80%, 3 days in the past, 75%. So it's really looking at how correlated today is with previous days. So it's going to be really, really valuable in that sense. It lets us get a good understanding of that autocorrelation, that self-correlation. Auto plot right here, but automobile plot right here, but really it's self. Auto in another language is can mean self, and here we're going to use in that term. It means correlation with self. And so how correlated is it? And really valuable for time series analysis, stock market predictions. Really interesting to see here after 1,500 days in the past, or was that 5 years into the past, there's really no correlation with itself, then it starts to turn negative correlation. It starts to turn negative. It's very interesting that movement starts to happen. And so it's really an interesting thing, can be very enlightening how you would want to engineer features in a time series type of prediction data set. Andrews curves. Here, this is an interesting plot. This is a very specialized situation where you want to use this plot. It can be very valuable when you want to understand the strength of your category. So what I mean by strength is how related is every category, how related is all the data in one category, let's say dog, cat, and horse. How related is all the data in horse to all of the others? So how kind of tightly packed together, how tightly, I'm just using distances here, how tightly correlated is the data, or closely clustered are the spots of data for each category. So you can see here where the black, you can really see it's a nice tight line here, the blue as well, it's kind of all together, whereas the white here seems to be very large, really spread out and stuff. So we're getting the sense that this category is tightly dispersed. It's not tightly clustered together. It has a fairly wide variation when we consider this actually converting many features into a smaller dimensional space. So this, although it's only showing us in 2 dimensions here, we're actually plotting things in a much higher, what we're considering things in a much higher dimension. Okay. Again, a very specialized plot that you want to really use this, but it can be very kind of enlightening in the sense of understanding your categories a little bit better. Okay, so another really cool feature that we have access to in Pandas plotting is this secondary underscore y argument. It allows us to make one plot on just the x-axis like we normally would, and then call this argument the second time we make the plot, and we'll plot it on the secondary axis, the right-hand axis, usually our secondary axis. So here plotting one variable, plotting another variable on the right side. This is really good when you want to look for really slight differences in the movement, usually generally over time as well. We're really looking for how things change over time. We're really looking for those more subtle differences. And this is kind of a handy feature, especially when you want to plot 2 different scales together as well. It allows that very quick and easy ability to do that. Here we have a larger or smaller scale on one side and then a larger scale on the right-hand side. But they're plotting kind of in line, and we're able to look for those kind of slight differences again. Another super handy and quick and easy axis feature is the subplots. So this allows us to plot many plots instead of on top of each other, kind of next to each other. You kind of choose how we'd like to do this. And so what's really interesting about this, you can look for really contrasting difference. What is really different? And so when you look at this one, this is kind of something, not all plot is going to fit every situation. In this, when you look at this, there's 2 spikes right here. It looks like the blue and the green both spike up here, but when you go to the secondary one, the second one, you see that really the spike only happens for one or the other. A little bit of the spike here for the blue, but nothing really in the green sense. I was kind of hidden the first time. So something to keep in mind is how you look at things is going to change your perception and what we're really able to see and understand from these plots. So the first one, we're looking for subtle differences, but that could kind of also hide things by putting things on top of each other. Just like the same problem with the scatter plot, where it's too much data and all the dots go on the same over top of each other. Plotting things on top of each other can hide things and deceive us a little bit. Here, this gives us a nice ability to contrast and really look for those differences as we look at really those patterns and trends that are different, that happened, hopefully over the same time, but where they didn't really relate like we thought. So next, we'll talk about the pandas highlighting function. This allows us to really highlight the min, the max, null values very quick and easy, and allows us to the ability to and find kind of things. If we have many rows in our data frame, just like we can just maybe quickly easily find the null values and really understand the rest of the row, or where the max and the min are occurring, and what the rest of the row would be like. Just quickly easily find that. I think I most often use this when I'm trying to communicate results. I'm trying to show that what I find, right? I want to communicate this to one person or the other person, and I want to say, this is the first time a user has, end user, my business partners have read this report, and I want to share certain things, high or low, maybe the null values, and really kind of explain, this null values, maximum values occurring in this row and this observation, so the rest of the details with that. And that makes it easier for them to see and find. You might be familiar with the data, and so it seems like it's kind of a little bit easier for would be easier to find out if you get familiar with it, but often the first time someone else is reading a report, you just want to make it as easy as possible so you can really concentrate on the insight, the value that you're trying to provide instead of the search for what you're trying to find. You want to make it as easy for them to find the answers that you provide. Let's get on to our okay, going over our mnemonic map from today's class. So at first we talked about the area plot and how really things move together. Really, the goal, or not the goal, I guess, one of the reasons that we use this plot is to determine better how different variables move together, how they kind of flow together, like this, that kind of watery feeling of this plot is that things are flowing together, right? How are we going to determine and see that in our usually time series type of data sets? Okay. We next talked about the histogram plot, and one of the benefits of this plot is that it removes a little bit of noise, or a lot of noise. We have the ability to control the number of bins, how much generalization are we adding to this, and kind of think about like what would the data set look like, what would the distribution look like if I had a bigger sample, right? So we're trying to remove a little bit of the noise, and that is often caused by the sample that we're receiving or that we've collected. And another one that we want to deal with is or that we talked about was the scatter plot that has a lot of, that really allows us to see trends and patterns in the data. And this is, although very valuable, I mean, still within reason to use lots of the time. It does have a problem though, is that we have a lot of data these days, and so there are lots of supplements, add-on type of things that we'll see in later classes of how to deal with this situation to enhance what we can get out of the scatter plot, because there's just really too much data, so we kind of lose, harder to see those trends and patterns because of the amount of data that we deal with on a daily basis, our normal data set these days. We also discussed the pie plot, which is pretty cool, the things we can do. I'm from finance. I really like pie plots. Data science in general doesn't really love them because our eyes are not good at telling proportions in a circular pattern. We can tell things are bigger or smaller, but by how much is actually, it's a little bit tricky for us to tell. So we really want to make sure that we're always going to note this plot if we do use it to compensate for that lack of our ability with our human eyes. And I think one of the cool things is we can explode out a wedge, highlight different wedges, different sections of this plot, and it makes for a really nice presentation effect if you're giving a presentation. We also discussed the box plot, which is super handy for highlighting outliers, kind of generalizes and kind of not ignores exactly, but you generalize the rest of the distribution to really concentrate on those outliers, and that's the goal of this plot. We next discuss the scatter matrix, which is plots many bivariate relationships altogether. And this is, it's usually too much to put into a final presentation, but it gives us as the data analyst the ability to understand where to go from here. What are we going to look at next? What are we going to do next? Where are we going from here, really, in that sense? We next talked about the auto regression plot, and that is looking at usually today with correlation yesterday, today with the day before, and we're looking at that relationship with itself. So how am I correlated with really my past self? Okay? Really valuable in time series predictions, something like a stock market or another time series related data set. We also discussed the Andrew curves plot, which we'll see the mathematics in the workbook. The mathematics are a little bit complicated. The goal of this plot, and really to think about what the purpose of this is allows us to tell how closely clustered a category is. So how related are all of the data points in looking at it in multidimensional space, bringing it down to 2 dimensions, but considering it in multidimensional space. So how is how closely related is one category, the row of one category related to the row of another category? So really focusing on the strength of categories by using this plot. We discussed the types of different formattings that we can have in a pandas plotting. We can do on top of, so we can put 2 plots on top of each other with the second, even if they're from different scales, with the secondary axis equals to true. We can also use the subplotting function to put plots right next to each other, above and below, or side by side, which allows for a type of comparison that we might miss if we put things, although putting things on top of each other can let us see small differences, they might also hide things as well. So putting things next to each other or above and below or on top of each other really depends on the situation when those would be valuable. And experimenting, see which one's going to work the best for you is really the best way to define that one out. We talked about how communicating results can be handy. We have the ability to highlight our plots, or not our plots, our data frames. And so if we wanted to focus on one certain thing, Pandas has something for us that's very quick and easy to use to highlight the max, the min values, the null values to really draw the eye there very quickly. And if you're trying to communicate something, some new data set that you might be familiar with, but someone hasn't read that before or seen the data before, very helpful to direct their eye where you wanted them to look. Hello, and thank you for joining me for our third data analysis camp, Pandas Hell Week, well, the first Hell Week. And this one, we're going to be covering a lot of Pandas plotting functions, trying to do a comprehensive look at as many of them as we can. So today we're going to be importing my standard data science libraries. I'm going to then deal with the taxis data set. And when you have, always a good idea to do the .info. You want to get the idea of the data, mainly the data types is where I already use the .info. Small objects, to floats, and small objects, and some integers as well. Okay, so starting off the EDA. Okay, so I find I find by default Pandas plot is not the most beautiful, and so what I tend to do is I tend to use one of these from the matplotlib style available, one of the predefined plots, and this is really how you're going to do a lot of the coloring, the background, text, and stuff like that. It makes Pandas plot look a lot nicer, truthfully. So, and this is what I'm just going to use solarize. So you can see here, plt.style.available, an attribute, so no parentheses here. You can get quite a few different ones, and lots of them look pretty good. So, just to give you a different a way to change your plots, and this would affect even Seaborn as well. Yeah. So plotting my numeric columns just to get a good sense of the data before we get really started here. So for feature and list columns, I'm going to grab, so the way we would do this in Pandas, we're going to grab the column, the one series, then dot plot, kind equals hist. plt.title, and then you're putting in our title right here, and then plt.show. Okay, so you get a nice little title right here, nice plot right here, get a good sense of the data, lots of exponential distributions that we're going to deal with today. Okay. So, I mean, that works to do it that way. We could do it that way. I wanted to also plot the object data types and get a sense of really everything in the data right here. So what I'm going to do is I'm going to go, if the feature is a data type object, I'm going to do the way you would do a count plot in Pandas, you do value counts and then a dot plot and just a bar plot on top of the value count. Okay. I'm going to choose a dark green and just get a good sense at the end of the categorical distributions, which are really important here. Kind of you can see exponential really, but there's just some values that don't occur a lot in this data set. And then row distribution as well, and we'll use those to play around with today as we go through the data set. And just again, always writing my notes to make it a lot easier to use these later on, so I don't have to go back and analyze this. Well, it's not that it's hard, it just is more time consuming than reading my short little notes. Okay, so Pandas area plot to get started. Okay, so here, just selecting 4 continuous variables from this. I'm not going to look at too many rows here. I'm just going to look at the first 50 rows, and then dot plot kind equals area. So pretty easy to use Pandas plot kind equals area. I can do some cool features in Pandas. Just right in the Pandas plot, I can go fig size equals 14, or parentheses 14 comma 15, so 14 width, 5 height, and change my plot right here. And you can also add the title right in your Pandas plotting function, which is just super handy. And you can just write directly in the plotting function. Okay, and so you can see the plot, and over it, and you're getting really a sense of how these different variables kind of flowing together. I think the one thing is when you're seeing it stacked on top of each other, you might kind of it's cumulative, right? So you might not get a sense of how they're moving differently. So one of the things that I like to do is stack equals false. It gives you a true sense of really how, as you can see here, these ones kind of all went up at one time and the blue went down. And you're just noticing that really why the distance not be tracking the fair, the tips, the total. It kind of seems weird, huh? And so it gives you a sense, a little bit better of a sense of the data, of how things are flowing and moving together. Getting into the histogram. So again, selecting a few continuous variables here. I'm going to go plot equals kind and stack equals true. So I'm going to stack these on top of each other. But you can see here, because we have so many exponential distributions, kind of a little bit hard to work with in this sense, because exponential distributions are just not the funnest to plot, really. They're hard to plot because they're just a long tail and you can't get a lot of detail. So what you can do is you can go log equals true. You can see we're not turning that perfectly back into a normal distribution, but attempting to at the very least. So now we can see what's going on in our distributions. A cool feature about Pandas is that we can stack these on top of each other and get a really sense of how each individual distribution flows by itself or is distributed by itself in truer senses. But they're on top of each other, so you can kind of get how they interact together a little bit. Again, with that log equals true is really important. Okay. And here, looking at just a few more variables, you can see how they're kind of at different scales, though. So comparing the total, the other ones might not make as much sense. So I got rid of the total there, or sorry, not the total. I got rid of the distance because it's just a bit. I apologize. Distance is a really kind of a much smaller scale than everything else. Deals in kilometers and then scale in miles. It's a different unit, and so it doesn't really make a lot of sense to have that one plotted together. So you just have to be careful as well. You have to be kind of careful what you're doing. So here now we have variables that are of the same scale, the same unit of measurement, so they're easier to compare all together. And then we have here, we can control the bins argument, which allows you to see how much it looks like there's a lot of data in this tail right here, but really if you see that, you can turn up the bins. Not so much. Maybe if you had a lot more data, you could see that, but again, not really so much. Another thing that we can do here is we can turn off the stack equals false to turn off the stack. I don't know if it made sense in this specific case, but just again, so you know about it. When you do that, it's good to turn down the alpha so you can see the detail of the other plots behind, so you can actually see these runs behind it. Maybe even going to like 0.6 or something might be a little bit useful in this plot and really get a sense of where the plots are behind it, right? Get a detail of each of these category, each of these variables and their distributions. Okay. The scatter plot. Not a lot that we can do with this, but you're going to go kind equals scatter and then x equals fair, y equals 10. So just two continuous variables. And you can get that interesting, we see here, as we saw in the presentation, there's this interesting kind of truncating going on between fair. I don't know, it's kind of interesting and it would be worthwhile to explore that, even regardless of the amount of tip. Fair seems to be kind of truncated. So maybe there's like, it probably has something to do with the taxes that they're limited, they can only charge you so much, even regardless of how much they drive you, which seems, I don't know if that's a good idea. Okay. So what we can do is we can play around with changing the color of these by one of our continuous or one of our category variables. The way that we would do this in Pandas, we're going to go logically select the logical indexing, the credit card. When payment is equal to credit card, I'm going to select those rows and I'm going to just do a plot on that. Scatter, distance, tip. I'm going to set my color load to blue here and important, I'm going to set my label to credit card. Notice here that I'm saving this to AX and then as a variable, and then column the next time we use is AX equals AX. To say, okay, make another plot, but put it on top of the plot that was already made. Okay, so payment equals cash, so I'm going to logically select use logical indexing to select the rows where it's cash, and then plot, scatter, distance, tip, and then the label green or the color green, and then give it a different label here. That way, when the legend comes up, it knows which one was which. And you can see it's very interesting that the people that didn't tip We're the ones that paid in cash. I don't think we're getting paid in cash as a taxi driver for sure. So we can see here, next ones, we can change the size by another variable. It looks a little bit like a convoluted calculation here. What I'm doing is I'm taking the tip divided by the maximum of the tip times 150. I find this really scales around 100 is what you're trying to make the S argument for the size of the variable to try and change this. You kind of run into there's lots of data, so you're not getting a lot of detail. You can see sometimes the tip is really high when the distance is really low. Sometimes, over these variables, the tip was quite a bit larger here, but you're not able to really get a true sense of what's going on in this. It's just so much going on and stuff. So again, kind of one of the downsides of the scatter. Getting into the pie plot. I wrote here to kind of be impartial. I like the pie plot, but lots of data scientists don't. So I wrote some positives and some negatives for you to kind of read through on your own. I think you have to be careful, and I think one of the biggest things that we talk about is the note function is really important to make this work. So what we're going to do is we select this right here. What we'll be doing is selecting just the mean by the pickup borough. Okay, so Bronx, Brooklyn, and Queens. And then what we're going to say is just select the fair column and then I'm going to plot just on one column, so one dimension of data, and then apply, adding some percentage signs right here, so you can see the numbers and how you're going to format those. So auto percentage, and then a note this right here. So it just makes a lot of sense to actually see this. So the two outside percentage signs are to make the actual percentage sign, and this first one is just saying this is a 2 decimal place percentage. And then you see you get a nice little plot there. Can add a title right here and add that. I'm adding a title line break n before, and gives you a nice little space before this. Changing that figure size to make it a little bit easier and nicer to plot. And then I think this is the coolest feature here is that we're going to do this explode. Okay, so it allows you to again section out one of the plots. I'm kind of separating everything a little bit, focusing on one a little bit more. I think this makes it look a lot nicer. Truthfully, it allows you to help our eyes see the proportions a little bit better. Again, it's hard to see. You can see that this one's bigger than this one, but by how exactly much? It's pretty tricky to see. Truthfully, okay. And so what I did here is I did the same thing that I did above. I plotted it, but I saved it as AX. So then I'm going to use for W and AX patches. With AX patches, when you call on a matplotlib, because pandas and even Seaborn is made with matplotlib. So you can use matplotlib to create the figure, you can set the label with it, and we can extract then all the objects inside of our plot with this AX.patches, and then iterate through them. Set the line width to 2.5, set the edge color to black. Makes it look a lot nicer, truthfully. We do this, and just really kind of makes the pie plot look a little bit more useful. Getting into the box plot. So box plot's pretty handy for outlier inspection. The cool thing here is a little bit of different syntax right here. So there's notice df.boxplot. I'm going to select the column that I want to do and then group by a certain borough, drop off borough in this situation. And you can see that really there's almost no variation in one of the boroughs right here, which is kind of interesting why there's no variation really for this one. Let's just have a set coming from Staten Island, I guess. You just have a set fee maybe or something. So it's kind of giving us some insights about the data really going through here. Looking at two variables now. You can do both of those by the drop-off borough, and you can see an individual plot for each one of those, which is again kind of nice. Some cool things that we can do is play around with lots of the colors, and just to show the amount that you can do with pandas, and for you to play around with. So you can go dictionary. Those boxes green, whiskers purple, mediums blue, caps red. This is just to show what this looks like. This is just a dictionary, right? Just a normal pandas dictionary or Python dictionary. And we just give this to color. So just giving it one color, we're now giving it specific colors for each one of the kind of parts of the box. You get kind of different colors here. Make it a little bit more unique, I think, as well. Okay. doing even more with this, we can go back, box properties, median properties, whisker properties, cap props, that's the prop sets of properties, and then giving it dictionaries, so line style, line width, and then colors, and changing on one of those. I don't know if this really looks, it kind of reminds me of Barney, that child's TV show. Does it look beautiful? Yeah, I don't know, but again, just kind of showing that you can do so much with this and have lots of fun, truthfully, and really make it kind of want to do a lot of cool things with this. Getting into the scatter matrix. And this is a plot that you use to kind of figure out what to explore next. Okay, so where are you going from here? What are you going to explore next? What are you going to go from your analysis? Because there's so many bivariate plots in this. The reality is you're probably going to use something in Seaborn a little bit more than the scatter matrix, so I'm not going to spend a lot of time on this. But this is a good introduction to this hist KWDS, different in Pandas than Seaborn. So just to note this, you'll see this a lot in Seaborn. Here we're going to control the lower level functions of one of the plots that makes up this plot, right? So very common way to do this. We're going to pass this hist keywords argument to bins and 10. So we do 10 across the diagonal axis and then scatter plots across each of the bivariate relationships. And when total intersects with total, we're going to do the univariate analysis across this diagonal. And it gives you some really quick, easy ways to see interesting correlation here, interesting truncation right here, maybe not so much in this total one right here. I'm kind of interested to explore this a little bit more. But these are really focusing on just what do I don't have time to explore. So, it's like 3 columns. You increase this, there's just going to be so many more columns or so many more plots to inspect. Okay. Into the autocorrelation plot. I downloaded a time series data set, the Google stock price, to be able to do this. And so we're going to do df2 and looking at this. So the way that it's pretty easy. Use pd.plot plotting autocorrelation plot df2 is or just giving it this one series, one column from this data set. So kind of univariate in lots of sense. There's not a lot of things that you can really do with this, but it still gives you a really good sense of when that correlation with yourself. So when today is related to itself, so looking at 500 days in the past, and then you start to see zero correlation as you get to 1500 days in the past. It's interesting that it's so zero and it starts to go negative after that. There's probably some way that you can use this in your stock market predictions or the time series data, but this is valuable to understand when that relationship with today starts to dissipate, starts to become weaker over time. Okay. So I put a link to another article to explain this, but I tried to include as much as I could about this article, about what Pandas purposes. It's kind of confusing how this works. It uses, kind of feels like it was made, it's a very old style plot, so it was made, lots of times you see in data science more linear algebra type of math. This is using sine, cosine, which is kind of common. You see it sometimes, but I'd say it's more, a little bit old school almost in lots of senses. So this is doing a way of reducing this down, many features down to a lower dimensional space. And so here what I'm doing is I'm just gonna bin a variable before I get started, just so I can bin the total right here. So bin the total to create total bins. So I have some categories to plot as I go through this. So I'm gonna use the total bin. So you're gonna select the columns and select the total bin, which I'm going to then color by total bin. I'm just changing the color map just to add a little bit of a texture with this one. It looked a little bit better to be able to see the different colors. I don't know if I love these different colors, but you really can see the difference between them. Okay. So what this is saying is, again, this is saying how much variation, you can read the stuff above, but this is saying how much variation is in any given category. So you can see here in the low and the medium categories, they're very tightly packed together, more closely packed together. The high, the pink color here is starting to show some variation, but really in the white, you see so much variation. So this is saying of all of the points, not just like one dimension or 2 dimensions, but of all the points in that row that we gave to our column, so in distance, fare, tip, tolls, total, for very high totals, when we bin it, it seems to be is that there's a lot of variation in this in these rows. They're not as similar to each other as possible. They're actually quite different. Okay? Kind of interesting. A plot that we would then supplement this with is to say, well, what's causing that difference? And we could use parallel coordinates to start to understand that. So do the same thing here, giving it the same columns, change the color by the total bin again, change the color map as well. And what we're getting here is this is a similar idea, but this is now going to show you how much variation is in each category, but by specific column. So we know there's a lot of variation in the total, or the very high category for total. But here what we're seeing is the features that are causing it is fair, not so much tip and totals, those are very similar. And then total again, lots of variation. So it kind of allows you to inspect your clusters. Very detailed, very specialized plot, but gives you a lot of very high level ability to do that, which is kind of interesting and can be useful in specific situations. So here we're going to do look at just I want to show some plotting formatting functions, some different things that we can do with the Pandas plotting. So here we can just change the line style to K dash dash to get a little checkered line or dashed line here. You can do add a legend. Make sure if you want to add legend, you just say true inside the plot, and then you add the legend right inside the plot. And we can do some formatting here. And we change the style just to have fun. Change the style to one of the seaborn style plots. And we're going to do here, this is the secondary axis. So what we'll do is I'm going to assign this to one. I'm going to assign this to an x array. I'm going to make one plot. And then in the next time I call this, make sure that I call x equals x and secondary true, secondary y equals true. So we'll do the second plot on a different scale on a different axis. And then setting y label left is to the distance, y label right axis, set label there. It's plot there. Layout and subplots, so we can use subplots here equals true. We're going to plot both of those in two different plots instead of right on top of each other. You can control the layouts, so subplots equals true, layout 1 and 2. So it's going to do one row, two columns, or we can do two columns and one row, which is what we saw by default. A cool feature in the Pandas plot here is changing the color, so I was having fun with that today. I'm going to go df.plot, subplots equals true, so I'm going to plot all of the histograms that are possible, the continuous variables that are possible. Dataset, you see all the exponentials right here, but we can, as we saw up above, we can also call we can change the layouts, 3 by 2 or 2 by 3. We can, as you can see, these are all exponential, so it's kind of handy to be able to choose the log equals true and start to plot this in a truer sense, or not a true sense, in a way that we can actually inspect this, because these exponential distributions are really not able to see very much, and so this log equals true is pretty handy. I don't know if I love this, but you could just to show that it's possible is that you can add a table to the bottom. This would be if you had a very small amount of data. And then the table equals true, and it's a good idea to turn off the axis, the x-axis set visible. Okay, so you're not seeing this bottom one right here, and you're putting a table on top of it. Okay. Very specialized when you want it, but again, Pandas is so handy and so much of features that you can do. You can do a lot of the formatting of the numeric variables in your data frame as well. Okay, so here what I'm going to do is I'm going to see precision equals 1, so one decimal place. Thousands equals, or thousand commas, so we're going to separate. There's a thousand somewhere in this data set. If you can see it, it's going to go 1, comma 0, 0, 0. You do a space if you want it as well. I wanted to then specifically format one column total. I wanted to show 2 decimal places. So I'm going to select formatter, and then I'm going to pass this total is equal to 2 decimal place floating point number. So you can see, you can kind of tailor this to each column as well, which is pretty handy. Precision equals 1. We'll just be doing the whole data frame completely. Okay, and then you can highlight. You're doing highlight null color yellow, so you can just do this right, and it allows you, very easy to find if you have a big data frame. You can start inspecting the rest of the row and start to really understand what happens in Murray Hill? Does it always happen in Murray Hill? Get a good sense of this, when this is happening, why it's happening, give you a good sense of really what's going on and why did it happen. And also highlight the min and be sure to do axis here. So it's going to go vertically across the axis, and one would go horizontally. And if you do horizontally max and min, you're going to have lots of pink right here, but of the whole data frame, you can see now, those are, you can highlight the columns that are less tip 0, fair minimum, 5, and then total, the lowest one as well. Okay. So lots of things that we can do in this Pandas plotting functionality, and really handy. There's so many quick and easy things that you can have really playing around with this as you use it on your own data sets is really where you're going to start to get good at this. Treat this as your reservoir of knowledge, right? Just put this in your cloud drive somewhere, and whenever you're doing coding, wherever you are in the world, you can come back and access that. I mean, I'd say all of my classes and any Python coding, truthfully, you keep them really nice and organized. Your old projects, you're going to often want to come back to them. How did I do that really cool thing a couple months ago? Well, I could think through it, but it'd be nicer if you had a little helping hand. Still want to type it out though. So you want to get to the point where your fingers are going to help you remember this coding, so that really even ChatGPT is another good thing. It's really handy. You really want to make sure you're typing out the coding because you'll never remember it if you're just copying and pasting. Really want to be typing these things out so that you eventually remember. Use your fingers to remember this much quicker and easier. So one time, like learning a language, the reason that we have to say a language to learn it is really an important step. It's because we use the muscles in our mouth to help us remember it. Same thing with Python. We can use our fingers, or any coding language, you can use our fingers to help our stupid human brain remember these things a lot faster. And so that's really the kind of secret to learning coding is typing things. Lots of practice, but really getting that, ingrained in your fingers within your muscles. Okay? So thank you so much for joining me, and I'll see you for the fourth data analysis bootcamp.